For 2.5 million years, human existence was governed by a single, exhausting imperative: keep moving. Paleolithic hunter-gatherers tracked migrating herds and seasonal harvests across vast landscapes, carrying only what could be easily packed in a sack. Survival depended entirely on mobility, so Paleolithic architecture was exceptionally temporary. Shelters were built quickly from light timber and animal hides, specifically designed to be abandoned the moment a local food supply dried up. Roughly 11,500 years ago, humanity discovered how to domesticate plants and animals. Instead of chasing calories across continents, early farmers learned to cultivate them in place. This data visualization shows how those erratic migration paths suddenly consolidate into fixed nodes. These represent the first early farms. By generating a reliable surplus of food, agriculture tethered human beings to specific plots of land for the first time in our species' history. Ceasing movement shifted human priorities. Instead of spending every waking hour securing the next meal or finding temporary shelter, societies could invest their time and energy into engineering structures designed to last a lifetime. No longer leaving every season, early farmers required materials that could withstand year-round weather. By mixing wet clay with straw and letting it dry in the sun, they created a highly durable, modular building block. Mud brick was cheap to produce and offered excellent thermal insulation against extreme temperatures. It rapidly became the foundational material for permanent homes across the ancient world. Inside these mud brick walls, the hearth, a central fireplace made of brick or stone, anchored the home. In regions like Neolithic Greece, builders constructed rectangular longhouses around these hearths, while early Mesopotamians developed tripartite dwellings, featuring a main central hallway flanked by connected chambers. These permanent partitions allowed for the separation of domestic life into distinct rooms for cooking, sleeping, and storage. This physical layering introduced a sense of domestic privacy and fixed social ranking, replacing the fluid, communal space of the nomadic camp with the rigid organization of early villages. As villages swelled into towns, communities required larger shared spaces. But scaling up buildings introduced a severe physics bottleneck: how to build heavy, permanent roofs over wide rooms without the structure collapsing inward. This schematic illustrates the earliest structural solution, the post and lintel system. Two vertical posts support a horizontal beam. The roof's weight pushes down in compression, while the lintel stretches under tension. The strict limitation is that stone has low tensile strength. If the gap between posts is too wide, a heavy stone lintel will eventually sag and snap under its own weight. To cross wider, higher spans, ancient architects developed the corbel arch. By stacking stones in horizontal courses, each layer projects further inward, counterbalancing the weight until they meet in the middle. By solving these basic problems of load distribution and structural spanning, early builders pushed past the limits of simple domestic housing. They now possessed the mechanical techniques required to construct true monumental architecture. Physics was only half the equation. Constructing massive monuments requires thousands of hours of specialized labor. Intense farming yielded immense caloric surpluses, feeding new classes of builders, architects, and priests who no longer needed to farm. We can see the results of this organized labor at Newgrange. This massive earthwork features a highly decorated entrance stone. It contains a precisely engineered interior chamber designed to capture a single shaft of sunlight at dawn on the winter solstice. Around 2500 BCE, this drive to shape the landscape culminated on the Salisbury Plain in England with the precision and immense scale of Stonehenge. The famous Sarsen ring is comprised of massive uprights topped by enormous continuous lintels. Using stone tools, builders meticulously flattened and shaped boulders weighing 26 tons. It stands as the ultimate mastery of prehistoric post and lintel construction. Moving multi-ton rocks from quarries kilometers away required centralized authority and a cohesive society. The scale of these megaliths proved they possessed the wealth to dedicate hundreds of people to decades of specialized work. This drive to erect permanent structures occurred globally. From the Mediterranean to the Near East, early civilizations used their newfound architectural skills to project political authority and religious ideology. In Mesopotamia, builders constructed ziggurats. This pyramidal structure at Ur acted as an artificial mountain, featuring grand converging staircases bridging Earth and the heavenly realm. On the island of Malta, communities quarried massive limestone blocks to construct the Gigantia temples. Dating back to 3600 BCE, these are some of the oldest freestanding monuments in the world, built to house elaborate fertility rituals. This era of construction transformed architecture into a technology for organizing time and social hierarchy. These monuments acted as celestial clocks to predict the seasons, and provided physical platforms where elites could demonstrate their authority over the landscape and the divine. By anchoring their beliefs to the earth with stone and brick, these early builders established a permanent record of their society's priorities. These monuments remain as a legible ledger of the social hierarchies and engineering breakthroughs that define the starting point of the modern world.